recording, and I just clicked stream right now. Okay, so we're live on Twitch. Okay, so for those of you on Twitch watching the stream, I run Tech Cemetery LLC as well as the Tech Cemetery YouTube channel. I repair graphics cards for a living. That's what my LLC does, and the purpose of these streams is to showcase how I go about diagnosing and repairing graphics cards live on camera in front of anyone to see. So if you have, let's say, a graphics card that you want repaired, I have a website, www.techcemetery.com. We're joined in the stream by Fyro, who may not be talking too much because it's 6 a.m. where he lives, and he hasn't slept yet. So say something, Fyro.
Hello.
Okay, so Fyro, he also repairs graphics cards. He primarily serves his customers in Canada, and his email is jeremy@shapiro.ca. I think he'll put it in chat later on in the stream. So for the very first card we have to start off with, we have a GTX 1070. So this is the first card I picked because I have to get through a couple cards today. As I took a 2-week, well, like most normal people, I took the weekend off, and now I have a huge queue of cards to go through. So, like I said, this is a GTX 1070. For memory, this card is not detected. If I'm remembering the customer's notes. So I should note that this card was not sent with a cooler because the owner has because this card is actually the MSI 1070 Seahawk, so it comes with an AIO, and that thing is kind of too heavy to ship. Oh, actually, let me switch to an overhead view. And let me bring up Twitch chat, because I forgot I have to interact with my audience. Yep, there we go. So that's Fyro's email. So if you live in Canada and you need your graphics card repaired, send him an email, jeremy@fyro.ca. Is it Fyro and not Shapiro?
No, Shapiro doesn't work.
So. Oh, okay, yeah. Okay, so it is the, and also, what's with the asterisk? Oh, that's right, because you're making correction. Yep, okay. So anyways, let's switch to the overhead view and open this card up and do a basic physical inspection. As you can see, the owners used packing peanuts. I utterly despise packing peanuts. They get everywhere, and I really wish people wouldn't use them. But I guess they are at least cheap. Let's see, does it only have a note in here? From the looks of it, no. Okay, so he's just sent the bear card, paste on it, so that's fine. Let me put this away. Okay, let's put this away as well. Here. Okay, so this is an MSI 1070 Seahawk. So the owner says that the card is not detected. I'm gonna hope that it's a living core because actually, speaking of which, okay, that's right. Because it's rather common for these older Pascal cards to have a dead core. So anyways, let's before we clean it up or anything like that, let's do a basic resistance or diode check. So I know in my YouTube videos I typically use a resistance check, but in for actual working I typically use diode as it's a little bit faster. So to start with, we're going to check 12 volts at the PCI Express slots, and we're perfectly good. Then we'll check 3.3 volts. We're good. Checking the first PCI Express lane, 0.5. Checking the next one, 0.5. Checking a random one, 0.5 again. Okay, that's good. We're going to go to the back and check the reference clock plus and minus. Reference clock plus, I think it's plus, it might be minus, and checking the other one. Perfectly good. Okay, now let's check 12 volts at the external A pin. So, let's see. 1 volt rising, so we're good there. Let's check, let's go to resistance mode and check the voltage rails generated by the card itself. So for the 5 volt rail, I think we should see something in the kilo ohm range. For a 1080 Ti, this would be about 1.3 kilo ohms, but 5 kilo ohms is more normal for a 1070. Now let's check 1.8 volts. This should be about 900 ohms. Anything less than, god damn it, 432. Okay, that's a really bad sign. Okay, let's move on. And let's check the PEX rail. This should be 50 plus, I would say. 76 ohms. That's perfectly good. And now checking the memory. 82. Hold on. 48 ohms. Is a Samsung memory? It is. That's why it's disproportionately low. Okay, so we're not short anywhere, but we do have an abnormally low resistance on 1.8 volts. So before actually, let's go ahead and check the PEX reset line just in case it's short. I do see this sometimes. And we have 6 mega ohms. Perfectly fine. So I can tell you right now that due to the fact that we have 432 ohms on our 1.8 volt rail, kind of suggests a dead core. But we obviously don't want to dismiss it as dead just yet until we've at least tried to fix it. So let's see if this thing has all of its voltages. I'm hoping not, because I'm hoping it's actually a fixable card, and this is in the 5% of cards with an abnormally low resistance on 1.8 volts that are fixable. That's what I'm hoping, at least. I could be wrong, and I'm probably wrong, but we'll see. Okay, let's switch to a side view and do the rest. Okay, so let's actually, we have to plug this in. Okay, to start with, we're going to check 5 volts, which we have, 1.8, which we have, V-core, and which we also have. And also the card is actually detected, and it's initializing. Or, what? Hold on. 0.7 volts. So on Pascal, 0.8 volt, if it's at, say, 0.8 volts, that means it just powered up. So after Pascal initializes, at least the GPU initializes, this usually typically drops to 0.7. So if we see, at first boot it's 0.8, once the GPU initializes, this drops to 0.7. So I should note that we do have an abnormally low resistance on 1.8 volts, so right off the bat I suspect dead core, but we could be wrong. So notice how it's so far hanging on post. It hasn't posted yet, so this might be an indication that we have memory corruption. And in fact, let's check the other 2 rails. Oh, okay, so we actually have 0 ohms on the memory, which is why it behaves like it has memory corruption, and we have 1 volt on hex. Okay, so let's first restore power to the memory phase, and maybe the memory is the source of our abnormally low resistance on 1.8 volts. Okay.
0 ohms. 0 volts on memory.
I'm sorry, what? Oh, that's right. That's
0 ohms.
Oh, yeah, my mistake. Yeah, that's 5 was correct. What I really meant to say was we have 0 volts on the memory phase. I just realized the layout of the circuitry is a bit different on a 1070 than it is a 1080. Because I know exactly what to check and where to check it on a 1070, but here it's a little different. So, anyways, for a non-working memory phase, there's a couple things that we want to check. So first, our first suspicion is that we have a problem with the PWM controller itself. This is an RT8816 or equivalents. You can sometimes see other chips like the UP1666Q, and there's a couple others. I don't remember them off the top of my head. So I'm going to first start by removing this 2-pin, just in case I have to do any soldering work later. We don't want this to melt, obviously. And that just went flying off. Okay, so there are 4 things that we want to check for a PWM controller. So we want to check that it gets VCC. We want to check that it has enable. We want to check that it has refin, and we also want to check it has a VREF, where refin is derived from VREF, and VREF is 2 volts. So first we're going to start by checking VCC. So we're not going to check the voltage just yet. We're just going to do resistance check to see that it has a continuity, or the resistor hasn't died next to VCC. I should note that I would say that the most likely cause here is that the controller itself is just dead. This is a rather unreliable controller. So checking for continuity. Is it this one, or Okay. Okay, never mind. Let me pull up the data sheet for an RT8816 and we'll go over which pin's which. And we'll also switch to a microscopic view. Okay, so VCC is, I believe it's connected to that large capacitor. Let's see. Okay, so first things first, this resistor is 1 ohm, 0 ohm, so we know that we have VCC because the resistor is not short, and, the resistor is not more than 0 ohms. If this capacitor was short, it would likely kill the resistor. So we do not have ground on this end, that's fine. And now we want to check enable. So enable should be, I believe it's this one here, one of these two. Let me just pull up the data sheet briefly. Okay, so enable is actually pin 3, which means that it is actually, so yes, it is this here. So let's just check if it's short. It is not. Okay, is it short on the other end by any chance? $432 ohms, so I'm going to say that's probably just fine. Let's see, what is this? Okay, now we want to check VREF and REFIN just to check for short. So VREF is pin 8 and REFIN is pin 7. That's fine, so that's VREF, and then REFIN is this. That's fine. Okay, so let's go ahead and plug it in and check those voltages. So we want enable, VCC, REFIN, and VREF. If we have all three of those, so 4 of those, I'm just going to go ahead and assume that we have a dead PWM controller. So who just joined? Akurian?
Grimax.
Oh, Grimax. Hi, Grimax.
No, hey. What QPU is it?
It's a GTX 1070. It's the reference board. This one's used on the this one in particular is used for an MSI 1070 Seahawk, the AIO. Okay, so this card is it has an abnormal low resistance on 1.8 volts, 432 ohms, but it's also missing the memory voltage. So we have to restore the memory power, and then we can diagnose the rest of the card if there's any issues. So first things first, let's check for VCC at the PWM controller. There should be 5 volts, which we have. Okay, now let's check enable. Zero volts. So let me just double check that again just to be sure. I can tell you right now this is probably being shorted. Yes, 0 volts. Okay, what we're gonna do is we're gonna go to diode mode, and what we want to check is to see if the enable line is being shorted while it's on. So we already know that it's not being shorted while it's off because we checked this already. So yes, open line, and when we turn on the when we turn on the card, this should drop to 0 volts. What? Hold on, I'm confused. Let's give it a second to turn off. Okay, let's try that again. So while it's off, it's open line, turning it on. It's still open line, and then turning it off. It gets briefly shorted and then rises. Okay.
A cap is shorted, maybe.
I'm sorry, what?
I think a cap
Um,
and cap is shorted.
yeah,
Right?
maybe. Grimax, no offense, but don't give me any suggestions, okay? This is not the point of this Twitch stream. So, if you don't know, the signal for the memory VRM enable is generated. Oh, sorry, no. The way it works typically for these cards, and I'll go over to an overhead view, is that it is attached to a dual NPN transistor. So what usually happens is that an early power rail turns on it shorts enable for the for the memory VRM, and then when the PEX rail turns on and P good is present on the PEX buck converter, it then shorts the signal, shorting enable. Okay, so let's look at it under the microscope. Maybe it's just physical damage. That's a rather common thing. Okay, so first things first, we're gonna see if this signal is shorted. So I sometimes see this capacitor over here die, and when it does, it shorts. It stops this dual NPN transistor from shorting signal, shorting enable. Let me go back to Twitch chat to see if anybody said anything. Oh, hi Levi. Anyways, checking this pin over here. So no, it's not shorted. Is this shorted? By any chance? No, it's not. Okay, so what we're gonna do is we're gonna check the voltage on this pin over here. It's okay, Grimax. It's okay. So we're gonna check the voltage on this pin over here, and let me see and it connects to this resistor over here. This will be a bit hard to measure. Okay, so anyways, let's plug it in and see if it's present. But I'm gonna do one more check before I do that. Ooh. I want to see if it's even generated. That's what I want to know. So let's see. What's the resistance of the resistor? Here. Zero ohms, and on this one we have 300 kilo ohms. Actually, we're done. It's not related to dual NPN transistor. I'm pretty sure it's just this one resistor. So let me zoom into the microscope one more time. If you're wondering where that shiny bit is from, that's my multimeter. So let's see. This is 300 ohms, 303 kilo ohms. Yes. So and at the bottom end, I believe we should have 1.8 volts. Let's check for continuity. Yes, so 1.8 volts passes from the bottom end of the resistor to the top end to supply enable for the PWM controller. If you want to know where this is from I'm pretty sure it's from my multimeter, but maybe it's user inflicted damage. Probably should have noticed it earlier. But anyways, let me go check what this is supposed to be on a donor board. We'll replace it and we'll see if the card becomes usable. Hi, hi Galaxy, Tim Yo. So this is not the usual time I stream. I'm currently trying to readjust my sleep schedule, and well, I figured that since I do want to look at every card I get on stream, if possible, but because my sleep schedule is not corrected yet, I'm just streaming now because I want to get some work done. So no, eventually I'll get to a point where I start streaming at about 9 p.m. most weekdays, and then I'll end at about 1 a.m. But for the time being, this is like a temporary thing. So if you don't know, this GTX 1070 is missing memory voltage, and we figured out that this resistor over here is 300 kilo ohms. This scratch I think is actually from measuring, but anyways, we have to replace it and see if the card becomes functional. Also, I'll be right back. Okay, so on another card, this resistor is supposed to be 10 kilo ohms. So we're gonna replace it with a 10 kilo ohm, and then we're gonna boot the card. So who's this?
Aquarium.
Oh, hey Kieran, how's life? So if you don't know Kieran, this card is I have a GTX 1070, not the card you're looking at right now, but it's missing memory voltage. It has 432 ohms on the 1.8 volt rail, and it's missing memory voltage. So we have to, and we found out that it's due to likely due to a dead resistor. So we have to replace that.
Is that the gate resistor?
I'm sorry?
Is that the gate resistor or something?
That's the enable resistor.
Okay.
Basically, it's supposed to be 10 kilo ohms, but this one's 300. So no, the one I took off was 300. Okay, that's soldered on. We'll let the card cool down for a moment. Okay, so for hot air, I use it at 500 degrees. Sorry, 500 degrees Celsius or 932 degrees Fahrenheit. I use 120 for air. Yep, it just takes practice. So even for memory chips, for memory chips, when I take them off, I use 500 degrees Celsius because I don't reuse them. I just throw them straight away, even if it turns out they're good memory chips. But when I install them, I use 400 and sorry no. Actually, let me check. What does my audio station say? Okay, so when I reinstall, I use 788 degrees Fahrenheit or 420 degrees Celsius. I think in your case you may have been heating it for too long. So I use a higher temperature than you, but I usually take it off as quickly as possible. Okay, so let's see. Is the card still warm? It's cool enough. Let's see if we now have memory voltage. And by extension, a working card. So for those of you who don't know, this card had 432 ohms on the PEX rail, which is not PEX rail, sorry, the 1.8 volt rail, which is obviously not a good sign, but we're not going to dismiss it as a dead core until we at least see the memory work. Okay, first we're going to check for a short at enable. I'm a little concerned that the resistor will just die again. Not short at all. Resistance mode. 10 kilo ohms, yep, that's fine. Okay, let's turn it on. Let's hope it works. 1.5 volts. It's initializing. Yep, 0.7, so it's initialized, but it hasn't posted, so it's likely gonna, okay, it's probably gonna post in about a minute with memory corruption. If you're wondering, this card will not overheat before it gets there. Pascal in general is insanely efficient at not producing heat. Which reminds me that I'm going to need a cooler for this card. And it posts. And the monitor receives a signal, I think. But there's no image. Okay. Let me go grab a cooler and then we'll run maths on this. Hey, Sataneth. So, well, whether you think the microphone is fixed is up for you to decide. So, Greg sent me a microphone. He sent me a shotgun mic. I was gonna buy one anyways, but not quite yet. But he decided to send me one that he got from Amazon, and that's what you're listening to now. I do harvest RAM from dead PCBs, if I think I have to. So if I don't, it's mostly for like GDR5, yes. For GDR6 and GDR6X, no. So basically, if you have like some really rare SK Hynix GDR5 and I don't have it available, I will harvest it from a dead card just to mostly just for testing, and sometimes I use if I think the memory is in good condition. But yeah. So yeah, I don't harvest them from, let's say, cards with dead memory MOSFETs. You know, I typically know when to harvest them. For example, in my last video, my last stream, I had an RX 480 errors on memory channel D. I took, in order to replace the memory banks, I took it from a dead, not dead, sorry, a P106 100. The card was actually working before I took the core off the board. I used the core for another card and for a test. And so the memory in that case was perfectly working. Just Taobao. It's you can just buy from Taobao or AliExpress. Ideally, you'd buy them new, but they're usually out of stock. Okay, anyways, let's recycle the cooler from this dead 1070 Ti, and we'll see if that card has memory errors. So for this card, I think I will actually have to recycle a memory module. I don't think I have that's right. I don't have Samsung GDR5 lying around, unfortunately. Put this over here. Yes, if you have a shorted 1-volt rail, it's probably safe to take the memory banks from it. Yeah, I have to fix the echo. It's I haven't yet decided on which sound blankets I want to buy. I'm thinking of just moving the stream setup to a different, larger room where there'll be a lot less echo, because it costs me less money to do so. But in general, yes, you can harvest memory chips from dead cards. As long as you know which cards to take them from. Like if you have, let's say, a dead memory, if the card has, let's say, memory errors, you may not want to do so. If it has a dead memory MOSFET, you definitely don't want to do so. But like, you know, if it's just like, say, short on 1.8 volts and it's a dead core, then it's probably just fine. Yes. Yes, I use stencils. Yeah, so I have to. For fan headers typically come off with the actual. Sorry, no, the socket, if you will, the plastic insert. You sometimes get stuck. So I typically just take the fan header off these cards, and then I put them on back once I'm done with the card. Okay, let's go ahead and run mats on this card. After I confirm that this is the mats USB flash drive. Yes, it is. Okay, let's go ahead and run mats. Yep, fire, that's why you should have just bought a new one. So for those of you who don't know, this card had missing voltage on the memory face, which it now has, by the way, but it hangs on post, so we suspect memory-related problems. It could just be dead core, given that this thing has 432 ohms on 1.8 volts, but let's just check the memory voltage first. Oh, hold on. And it's already artifacting. What? I wish you guys could see this. Is the cable not inserted correctly? Let's just check the memory voltage. 1.35. Yep, that's fine. That's for this. That's the standby voltage. Yeah, I'm seeing all those weird flickering dots as well. Anyways, mats should run, and then it will tell me something. Maybe the HDMI port's dead. Anyways, I have a feeling that this card has more problems than just memory, and it's not just the memory. Yeah, Galaxy Timio, I suggest you just buy already ball chips. You know, I personally, I don't have the time to reball every memory module that I use from a donor board. Typically speaking, I only reball them as a last resort if I don't want to waste a month waiting to have them arrive from China. Like for GDR6, GDR6X, I just have them all lying around anyways because they're so common and it's just not worth my time. You know, it's not worth the $3 savings to reball each memory module one by one. So for those of you who maybe just joined stream, this 1070 has 432 ohms and 1.8 volts. It was missing memory voltage. We replaced the resistor that bridges 1.8 volts to the enable for the PWM controller, and it now posts after a minute, but it has flickering artifacts. I don't think you can see it. And it's currently running mats. Also, who just joined the Discord? Oh, it's Greg. Hey, Greg. I can't believe you're still awake.
Talk.
Yeah, I can tell. This is well past your bedtime. Is it still the cats that's keeping you up?
Yep.
Yeah, I was thinking I might as well go to the basement and repair shit.
You could, yeah. I mean, if you're gonna be awake, you may as well be productive, right?
Yeah, I got 3 customer cards yesterday, so I gotta diagnose them.
Oh, and Greg, he's using a mic.
I know, and it's so good.
So you don't know, this card is running mats. 432 ohms on 1.8 volts. Missing memory voltage, we restored memory voltage. Now it's running mats. It has this weird artifacting on screen. I think there's something a lot more wrong than just some memory bank. Yeah, I do think I'd still be working on video cards. RTX 3090s aren't getting cheap anytime soon. You know, I think those would still be at least 1,000 plus, and that's worth my time to look at. Of course, all I'd be repairing is RTX 3090s, but that's fine. And there's also the fact that typically when graphics cards go cheap, broken graphics cards go cheap as well, and then it's easy to get them broken from say eBay or whatever.
It's hard to believe, but 1080 Ti's used to be $100 on eBay.
Yeah, broken ones. Yeah, used
That's
to be.
cap.
Yeah, I remember the very first graphics card I ever bought broken for repair and fixed. Also, by the way, just putting it out there, it was a GTX 1070. I bought it for $70. I sold it like I fixed it that day, and then sold it for $190. Like I was like, it was a rush. It was one hell of a rush fixing my first card and then making some money out of it. It was a really awful repair too, being my first repair, but yeah, it was a fix. Oh, that's true. That's true. But a lot of broken cards would still at least end up on eBay, and I would do better than most people. This thing is taking an awfully long time for just memory errors. So anyways, let's go look at another card very briefly. So in queue I have, oh hold on, I don't want everyone seeing this, so let me just change the camera. Okay, so in queue I have a couple cards, and I'll let the viewers vote with by putting a chat in Twitch. So I have two 3080s that are intermittently detected, or so the owner claims. I have a suspicion that he's done something wrong, and that they're not actually broken. I also have a RTX 3090 Asus TUF. I have an RX Vega. I have a 5600 XT. So the 3090 it's just not detected, and those are my choices. So 3080s, two 3080s, one 3090, Vega, and 5600 XT. You guys can pick what you want to see repaired. Just let me know in chat. Oh dear, 5600 seems to win. Well, we'll see. Any other votes? To my viewers? My only 20 viewers. Okay, it seems like the 5600 has won by an overwhelming vote. Let me go grab it, and I'll be right back. The TUF cannot because it is physically damaged by the owner. He mentioned such. He took it apart, cleaned it, reinstalled it, and then it was not detected. I'll be right back. Okay, so for those of you on stream, this is a this first card we looked at, who just joined at least, 1070. Unfortunately, it has 432 ohms on 1.8 volts, and was missing memory voltage. We restored memory voltage. It's currently running max, but it's artifacting, which it should not do. This is likely a dead core, but we're gonna let it run for another 10 minutes. If it takes too long and it just interferes with the stream or work or repairs, I'll just diagnose it off camera and let the owner know what I find. Also, I'm gonna take a minute break because I want a sandwich and I haven't ate anything today. Okay, so unfortunately it seems like maybe maths just isn't gonna power off. I sometimes change the configuration files, but in either case I want my test bench back. So we're gonna plug in the USB maths to see if the thing ran and completed, and then in either case, okay, actually yes, it did complete, believe it or not. GP104. Yeah, okay. Let me show you the screen. So as it turns out, I guess it's just not set configured to power off. I sometimes have to change the configuration files for different types of cards. So let me switch to the screen view. Okay, so as you can see, we have a match report. We have errors on B1. So I'm gonna go replace this off camera, or I don't have a replacement Samsung GDDR5 module lying around, and I'm not gonna waste everyone's time by just by doing it on stream, as that'll take forever. Anyways, we're gonna just skip to the next card. So this card has 182 ohms. Hold on. So like I said, this card has 432 ohms on 1.8 volts. It was missing memory voltage. We restored memory voltage by replacing the resistor of the bridges 1.8 volts to enable, and then now it throws errors on B1. Like I said, I'll just do this off camera. Whether the card will be finally fixed or not, I'm not too sure, but we'll see eventually. So let's pull out a 5600 XT as requested. Because my customers are not efficient with how they pack things. I kind of wish they would be, though. If you don't know, this customer sent actually two cards. He sent both the Vega and the 5600 XT. I don't know. Oh, I would guess that the 5600 XT is in the 5600 XT box, but we'll see. Maybe he switched it out. So let's I'll put this box away, and we'll get to the Vega probably next stream. As I want to, if I can, I'll limit the AMD cards so that there's only at most one, maybe two per stream, and also so that I can make sure that there's at least one AMD card each stream. I can tell he has not used very much padding in here. Or in other words, none at all. So yep, this looks like a 5600 XT. It's the it's an XFX, if you're wondering. I think it's the raw. This one. Actually, before we open it up, let's see if this thing has good PCIe lanes. It's rather common for people to insert these into mining risers, put the riser backwards to the motherboard, and kill the core. I hope it's not one of those. That would be kind of dull. So checking first PCI Express lane, 0.85, next, 0.85, random lane, 0.85, yep, that's good. Checking reference clock plus and minus. That's good, and good. Checking PAX resets. Okay. So, no, it does not seem like this is PCIe riser damage, so that's a good sign. So, let's first start by checking 12 volts before we take the card apart. That's good. Checking 3.3 volts. That's also good. Checking 12 volts at the, oh, hold on. I just realized, it's not even in view. Okay. Let's start again. Let's start again. So, first PCI Express lane, 0.8. Second PCI Express lane, 0.8. Random PCI Express lane, 0.85. Again, perfectly fine. Which we already checked reference clock plus and minus. So again, 0.85 for reference clock plus and minus. Yep. And PAX reset's fine. 3.3 volts is fine. 12 volts is fine. Now checking the external 8-pin. Not short either. Okay, let's take the card apart, and actually before we do that, let's check the 0.75 volt rail here. 9 ohms, that's perfectly normal. Let's see, can we check the SoC rail from here? No, we can. Let's see. SoC rail. Can I reach? Yep, that's normal, 2 ohms. Checking, I can't check the memory or the memory controller from here, so we'll just take it apart. Oh, hold on, 2 more screws. Probably not. It's rather common. A lot of these miners or whatever, they get what they think is the super bright idea of middlemaning between, say, eBay's broken cards lot and me, and that they can get cards for super cheap and make a profit or whatever. But they often get screwed over because there are a lot of people like me who just buy graphics cards off of eBay. Oh, as for the repair wiki, it's kind of trash. A lot of the stuff there is actually just transplanted from my videos. Sorry. My early videos, by the way, where I make some mistakes here and there. So right off the bat, looking at the die, that looks like, hold on, that's kind of an interesting thermal paste. It looks almost like Colgate toothpaste. Hold on. I'm not sure if you can see the color.
What the hell? Is it green?
Yeah, it's green. So it looks kind of like Colgate toothpaste. And in fact, let me show you what this looks like under a microscope. Yeah, that's a thermal paste. Kind of looks like Colgate toothpaste. Whatever, it doesn't matter. Let's diagnose the card.
Wait, it might actually be toothpaste, because I don't think, from what I'm seeing, there doesn't exist blue thermal paste.
You're right, it might actually be toothpaste as a joke. No, there's no documented things about increasing knowledge about power rails. And I'm not gonna waste my time documenting it because if I'm being frank, like I said, it's a waste of time. If you want to learn about fixing graphics cards, you just have to start working on them and figuring it out yourself. Okay, so we already checked the SoC rail, 2 ohms, that's perfectly fine, minus 0.1 ohms for my probes, so that's good. We already checked the 0.75 volt rail on the back, that was 9 ohms. Checking the 1.8 volt rail, 1.8 kilo ohms, fine. Checking one of the 5 volt rails, yes. Oh, okay, we have another short on 5 volts, just like the last 5700 XT. That's kind of lame, but yeah. Okay, anyways, let's check the memory. So it's rather common for the memory phase to short on these Navi cards, and when they do, it's typically because of dead core, not a dead memory. So we have 28 ohms, 29 ohms. This is normal because we have Samsung memory. Now let's check the memory controller. These often go short as well. Usually the source of the short is the core itself, and we have 10 ohms, perfectly fine. And if we check the 5 volt LDO, 1.2 kilo ohms, perfectly fine. And for those of you who are not here, we checked the 0.75 volt rail, and this was 9 ohms for memory, and again, that's perfectly fine. Yep, there we go. Okay, so we have a short on 5 volts. This is, in the last case, this was due to it. Oh, hold on. What's this? Or, I need more light, hold on. Let's look at the card under a microscope. There's something that looks weird to me. And somebody's been screwing around and has been a little bit stupid with this card. Okay, let's see. Can I get it in focus? What do you notice here? Like I said, some idiot has decided to open it up, decided that they could fix the stuff themselves, fucked up the card, and now I have to look at it. I would wager that the source of our short on 5 volts, and is that flux residue? Looks like it. Is that even the correct part? 8713? Let's see, that's burned plastic for sure. Oh yeah, burned and chopped off. Okay. Basically, some idiot has decided to repair this themselves. And I'm guessing maybe even the person who sent it in. But yeah, we have to fix this. Okay, let's take apart the front and back plates. Who's this?
It's Greg.
Oh, hey Greg. Back again, huh?
Oh, 29 viewers.
Oh. Okay, so for all the brand new viewers, we have a short, for this card we have a short on 5 volts. And I'm surprised it's not short on 12 volts as well. But basically, somebody's made a prior repair attempt where they've destroyed most of the card because they watched one of my videos and they think they can do everything that I can do. Apparently my job is that easy. But like I said, we have a short on 5 volts. We have to fix this. We have PCB damage, again, due to prior repair attempts. And we have to figure out why it's short. It's probably not... there might be some naturally occurring faults that we'll also have to get to. But for the time being, we have to fix the prior repair attempts. And then we can get to the possibly naturally occurring fault. And there's even more flux residue.
And Chris Fix.
There's what? Oh, Chris Fix. Is he here?
Rastex and Chris Fix.
Oh,
He's watching the stream.
okay. Okay, so for those of you who just joined, we have a short on 5 volts. What appears to be a customer repair attempt. I'm not sure why they do this. Let me switch over. There we go. So you see that PCB mask? That's kind of ripped off. So again, somebody's been doing something wrong here, as well as here, on this one here, yep. And to make it much worse, we have what appears to be a, oh give me a second, my magnet's stuck to the board. We have some work that appears to have been done here. I'm a little worried that's not the correct buck converter, APW87138. It might be, but also some burn and some damage around here. Anyways, let's start with the source of our short. It's very likely just one of those two power stages. So let me go grab my thermal camera and hook up a power supply, and we'll confirm the source of our short. As always, we're going to start at a GPU safe voltage just in case it gets passed through the core. Probably not, but we have to check since probably not, given that we were not short on 12 volts, but we'll see. Why does it have to be such a small inductor? Let's see. And it takes, at 0.7 volts, it takes 8.3 amps. So based off the power consumption, actually let me change probes just to make sure, in case it's not my probes that are accidentally touching the ground end of a capacitor. And also, hi Chris Fix. If you don't know, Chris Fix actually repairs graphics cards as well. He has a shop in Germany. If you're around the EU, you can you can definitely send it to him. Okay, so as it turns out, yes, this card takes 7.5 amps and 0.7 volts at the 5 volt buck converter over here. So right off the bat, I think it's probably just a capacitor given the current consumption. But of course, we need a thermal camera. So let me go grab mine. I'll be about a minute. Okay, so this card is taking 0.7 amps and 0.7 volts and 8.73 amps. It appears to be a capacitor near a power stage. Hold on. Let me see. I'm gonna just look at the back first, just in case I have it wrong. So the single hotspot that I see is over, let me see. It would be about in, well, first there's the probes, but that doesn't matter. It's over around here. That's right, so over here, more or less. I'm worried it's maybe some solar blob. Okay, anyways, let's look at it under microscope. So it's definitely getting warm, but it's not that warm, oddly enough. Let's try to turn the board over, see if we can see a crack on the capacitor itself. Not on that end, and again. Is that a solar ball? Hold on. Anyways, in other case, let's just take it off. It's we're just wasting time at this point. It's not the Kian Lee thermal camera. It's the Thermal Compact Pro, I think. Actually, hold on. I just know. Actually, yes. Thanks, Sataneth. I just noticed. If we go to a side view, notice how some of these capacitors are tilted, shifted, and they definitely look dirty. Okay, this is a mess. Honestly, I'll be upfront and say that if you send me a card that looks like this, where it needs possibly lots and lots of work, I'm just not gonna fix it. I mean, there's flux everywhere, we have burned plastic, we have whatever the hell that is there, and then we have all these capacitors that are bulging and not in place. Let's take off that supposedly short capacitor. I say supposedly because I think this thing has lots of problems. If the capacitor, if I can't take off the shorter component and have it run, I'm just not going to work on this card any further. This thing needs a lot, and I mean a lot of work. As you can see, the capacitor pad's still stuck on the board itself. That's okay, we'll just replace it. It's not like they're expensive or anything like that. Anyways, let's check for short on 5 volts. If you hear a beep, that's because we're still short. Still short. Okay. That's just great.
Check Twitch chat.
I'm sorry?
Check your Twitch. Check your Twitch. The chat.
Okay. Sure. What's up? What?
Yeah, Satanif has a point.
Oh, Jesus. He's... Wow, I can't... Wow. I can't... Yeah, you're completely right. I can't believe I didn't notice that. The power stages are facing different directions. Wow.
So the gate is probably shorted.
Yeah. That's...
I'm gonna unmute just to say this. That's ridiculous.
I can't believe I didn't even notice that. It's like you don't think of something like that
It's a
happening.
stupid thing to
Yeah.
have.
Short on 5 volts, and with a power stage having the wrong area orientation.
Somebody worked on this card that shouldn't have, and they probably sent it to you because they're really bad or they're trolling you.
Wow. I can't believe. Yeah. Wow.
Greg,
They put the power
there's
stage
toothpaste
in the
on the GPU.
Yeah, there's toothpaste on the GPU. Somebody's trolling me. I think someone's trolling me. They put toothpaste on the GPU. They have the power stage in the wrong orientation. Every single capacitor on this board, every aluminum capacitor is, let me just show you, tilted. So if you look, just turn over, notice how they're not straight. So they've replaced all these capacitors here, and that's like, what the hell? You know what? I'll tell you what. I hate doing this, but I think most people would cut me some slack given the condition of the card and the fact that I feel like I'm being trolled. So what I'm gonna do is I'm gonna put the power stage in the correct orientation, and maybe fix one more thing. And if that doesn't fix it, I'm just gonna put it back in its box and send it back. So I have to take off. Actually, no, I don't. No, I don't. So. Yeah. I'm gonna just... Should I take off that capacitor on the back? No, I don't think we need to. And I guess if it explodes, whatever, I'll just replace it later. I need a bigger iron tip for this part.
Someone's got to look it up in Twitch chat right now to see if that orientation of that driver would send 12 volts to core.
It's probably not. Probably not. It's the V core, so even if it did, it would be safe. So, despite the fact that it was backwards, we still have a short on 5 volts. I mean, it could just be the PCB. No, that's the outputs. But, then again, hold on, what's this? Notice this here? Okay, let's clean that up as well.
Looks like a $400 repair.
Yeah, I should charge the guy $400. I mean, what the hell? Like, this thing is... Honestly, what I should have done was just said nope, and then not bothered fixing it. But
You should have stopped before you started working on it and be like, yeah, this is going to cost $400. And then he says yes or no. There you go. There's your answer.
yeah, it's okay. Well, I still get a $30 diagnostic fee, so it's not like spending an hour on this is a waste of time. Yeah, both of these look completely screwed. Thanks to some idiots, I should say, who decided that they could fix graphics cards after watching 1 or 2 videos.
Also, they don't have the same font, so one might be fake.
Oh, actually, are they the same font? Or maybe it's just the outlining, but the batch is different, yes. You're right, the batch is... No, they both have a different batch. Notice how all the other ones end with 8, this one ends with 6, and that one ends with 0. Yeah, so they're all foreign, okay. Let's just clean this up. Hold on, is the board itself actually torn? I think it is. Okay, let's just take the whole power stage off so I can see the board damage under it. This should have been a no fix, let's be honest. This should have been a no fix. Hold on, are they all outputs? Or... Yes. So those pins are actually all output, aren't they?
Oh wait, I thought it was flush, but that's ripped copper.
Yeah, that's ripped copper. So somebody's decided to rip the copper thinking that it was a good idea. You know what? We'll inject a few volts onto the card again, and if it turns out if we don't have like some dead obviously short components, I'm just gonna send this card back and tell the guy and charge the guy $30 for wasting my time. Okay, at 0.7 volts, the card takes 0.12 amps. Oh, hold on, let me just focus so you can see exactly how much of a disaster this card is, Enchanter. There we go. Somebody's done that. They've decided to bridge the output of the solar pads, and of course rip the board. And also they installed a power stage wrong on one of the V-core MOS phases.
And there's two spaced on the GPU.
Yeah, yeah.
That's basically the icing on the cake.
Okay, let's just check, before I wrap up the voltage, let's just check that the 0.7 volts that I'm injecting does not get passed to the GPU. So checking this, we have 0 volts. Hold on, yep. Checking memory, 0 volts. Checking memory controller, 0 volts. Checking the SoC rail, 0 volts. I have to check the, hold on. Checking the 0.75 volt rail, 0 volts. Okay. Let's ramp up the voltage then to 5 volts and see what gets warm. So 3 volts, it takes 0.6 amps. Can we spot this? Wrapping up to 5 volts. Okay, 4.9 volts, 1 amp. Okay, so our shorter component is maybe just the power stage. Let's see. And actually, no, it's a capacitor, I think. Or, so it's about in this vicinity, one of these components around here. Or maybe on the back. Actually, let me check the back. Yep, it's in the front. Okay, let me grab my alcohol so it's obvious which component it is. That resistor? Hold on. No, the power stage. There we go. It's the power stage. Who would have, well, color me shocked, right? And in fact, we can actually see the hole. Yep, okay. Anyways, I'm going to take off the 2 power stages that the owner puts. And hopefully the card has no other severe problems, but I'm not hopeful.
Did you check if the core was backward?
The core is not backwards. Thank God it's not backwards. I swear to Miles, if I ever get a backwards core, it'll be I know it'll be Miles who sends it in. I'm sorry about that background noise. That's my apartment building. I don't know why. So the goo is to check if it's shorted. So by putting alcohol on the board, if it burns off, well, then we know that our shorted components is nearby, and that's because shorted components get so hot that they can burn alcohol. Unless, of course, you're talking about flux. Yes. Okay, let's go back to resistance mode and check for short on 5 volts once again. And we are no longer short on 5 volts, so yes, likely one of these two power stages was a sort of source of our shorts. I'm not going to reuse them, they're, I can't even believe they were installed like that. So let's look at the actual card itself, again, under a microscope. Is that a rip pad? Yes, it is. And is the pad on the power stage? Let's see. No, it's not. Or no, no, that's flux.
They both have it missing.
I'm sorry?
The one above also has it missing, it seems.
Fyro, can you look at the datasheet and tell me if it's connected to anything? 30, 20, 45.
I'm looking.
Yes, it's the low side gate. That pin is for the low side gate. Is it missing on both? Let's go check the upper end. Missing here as well. Missing here. And it goes to a veer here. You know what? I'm not gonna fix this card. Nope, no fix. I'll charge the guy $30 for my for wasting my time and sending this crap in, and he can get his card back in this condition. I mean, the guy has toothpaste on his GPU. He has extensive board damage done by some prior repair attempts, and then he has a power stage that was installed in the wrong orientation up here. I'm not gonna look at this card. I'm not gonna fix it. It might be fixable, but this is a waste of my time. Let me go put this. Let me go put the guy's parts and his stuff in a bag, and I'll put it back in his box.
That's savage. Doesn't even put it back together.
Oh no, I'll put it back together. I have some Colgate in my bathroom. I'll use that. No, I'm just kidding. I'll use actual thermal paste. But like I said, I'm not fixing this. Waste of my time. Yeah. Oh, I'll put the parts back into a bag. I'm not gonna put it back on the board.
I don't
In the
understand why
future,
the pads were missing on both MOSFETs.
Yeah, both power stages are missing their low side gate pads. I'm not gonna work on this. Nope, not at all. Waste of my time, and to be frank, I shouldn't swear, but I utterly hate people who do this to cars and then send it in for repair. This is not, Tech Cemetery is not some backup repair service after you screwed up your card and then made it borderline unfixable because you thought you could play technician because apparently, my job is super easy. If you think my job is easy, go make a competing graphics card repair service, go make a YouTube channel, go make a Twitch channel, and then make a Discord. And then after you put in a year and, oh wait, that doesn't belong to his, you'll understand that sure, maybe the work is not super difficult, but I didn't get here in a day. And that's not his either. I would not.
heck, I don't know if you want to take any more cards like this in the future, right? You probably just want to reject any card that has had work done on it.
It's not the work done that pisses me off. It's the quality of the work. So if you replace one resistor or you bring it to a repair shop where they've properly tried to diagnose the card and done everything okay, right? I'll look at the card. It's fine. I get cards from that are typically have prior repair attempts. It's fine. What's the problem is that it's the quality repair attempts. Like, were you here for the entire stream? Is this plug slots? Yes. So
Yeah, I saw the DR Moss problem.
Yeah. So this DRMOS was actually the wrong way around. All of these capacitors are bloated and not installed correctly. These two have ripped pads. They're missing the low side gate pad, and then this appears to be toothpaste. And then there's even more flux around here. Like this is a waste of my time. When this thing originally died, it would have been an easy fix, except that somebody decided to fix it themselves. Hence now it would take me hours just to get the card into a bootable state, and there's no guarantee it'll work. Anyways, I'll put this back in its box. I'll put it back together later, and then, while we're at it, let's look at the other card that this guy sends. So his card is a Vega 56. I already have a feeling it's going to be a disaster as well.
It's going to be missing the current VA core and the plug bag.
Who knows? Maybe. Okay, next card. If I remember right, this is a Vega 56. The guy is probably a miner, given his two AMD cards, both of which are known for being good miners. Or maybe it's not a Vega. Actually, yes, it is. It's actually one of those nice ones. It's a gigabyte. Hold on. Okay, Vega 56. The first thing we're going to do is look for prior repair attempts given the last card. So looking at it just like this, I don't see any evidence of flux, at least on the sides. I don't see any shoddy work. None of the capacitors are out of balance. Anyways, let's take it apart. This one actually no, let's check the PCI Express lanes before we take it apart. Okay, in diode mode, checking PCI Express slot, 12 volts. We're good. 3.3 volts. We're good. First PCI Express lane. Second PCI Express lane. They're both good. Let's check reference clock plus and minus, and then PAX reset. So PAX reset. Okay. Reference clock plus, I think, or maybe it's minus. I don't ever remember the order, but they're both fine. Okay. Let's check 12 volts at the external 8 pins. That's fine. And the other one, that's fine. Oh, I'm sure. I'm sure. And hold on, is it still attached? Yes, one screw. Yeah, as far as I know, basically all Vegas are out of warranty, as far as I know. So this one doesn't actually seem untouched. So I'm going to take a guess that it's the owner. The owner himself doesn't work on the cards. He just buys them broken and hopes that they can get fixed. So the last 5600 XT with all those problems, probably not his work. Anyways, resistance mode as is usual, and wow, I actually don't know the rails for this card, so we can hold on. So that's obviously 12 volts. Let's start with this should be the PEX rail. Or what? Hold on. Or no? So okay, there we go. 14 ohms. That's perfectly fine. This is probably 12 volts. Checking what I presume is the 1.8 volt rail. It should be 1 point something kilo ohms. Usually 1.8-ish. But we have about 2 kilo ohms. That's perfectly fine. Let's check the memory controller. 21 ohms, that's normal. Checking both 5 volt rails. I think the tab is 5 volts. Maybe not. Let's check this one. Actually, let's do continuity just to make sure. So one of them will be 12 volts. Which means that this is 5 volts, and given that they're both the same type of LDO, that means the top pin is 5 volts. So this one is 5 volts and we have 1.2 kilo ohms, and this is also 5 volts at 3.5 kilo ohms. That's fine. And let's check the HBM memory. So that's right, it's over here. 35 ohms. Let's check I think that if I remember right, this is a 2.5 volt output. Maybe, I don't know. I know they have one on Radeon 7. I'm not sure if Vega has one. And that's not short either. Okay. So we're not short. Let's go ahead and plug it in. Actually, there's another 5-volt LDO. I just realized. This over here. So I'm guessing this is 5 volts. 280 ohms. Okay, let's see this one. $420 ohms. Something very high. 3 kilo ohms and rising. Okay, let's just check for continuity. Which one is 12 volts? That's 12 volts, okay. I'm guessing one of these two is 5 volts and the other is likely the feedback. Continuity again. I'm gonna guess that these two are 5 volts in the middle. Or maybe ground. I'm gonna guess this is 5 volts. So 420 ohms. That looks a little low, just off the top of my head, but it could be fine. Anyways, let's go ahead and clean off the GPU and then plug it in. Okay, let's plug it in and see if what we're missing, if anything. I have a suspicion dead core, but we'll see. Yep, I would bet on dead core. So this custom description is that the card is not detected from memory. I could be wrong, maybe, but if it was detected and hanged on post, I wouldn't have even accepted for it repair. So checking vCore, 0.9 volts. Let's see. Does it rise? What? It just powers on. Let's do that again. Okay, so this is not going to be a fix either. Either there's nothing wrong, or it can, or it crashes in the drive install, or has crashes in the load. If it's a crash in the load, it could be a VRM problem, but usually for these Vegas, it's the memory dies, or at least it starts dying. So unfortunately, it seems like this is not going to be. Actually, let me just look at the custom description. I need to go back to an overhead view so you can't see his details. But he'll tell me, it'll say what's actually wrong with the card in his notes. So Vega, RX Vega, what does he say? Okay, so he says that the card turns on, but dies right away. Okay, so maybe there's a problem. Anyways, let's put the cooler on and just boot into Windows and see if we can replicate his issues. This guy's whole stack is a waste of my time, honestly. I much prefer it when I don't have to deal with Vega or 5700 XTs with awful prior repair attempts. If you're wondering why I just use one big blob and the world's cheapest Chinese thermal paste, it's because it's just for testing. When I repair a card, if I repair a card and I have to send it back to the customer, and of course I send it back to the customer, but when I repair a card, that's when I use my good thermal paste and apply it properly. But for testing purposes, we just use what we have available. And usually the cheap stuff because it gets wasted instantly. So anyways, the owner says that the card comes up right away and then dies instantly. So what we want to see is whether, let's say, the fans go to max speed when the card dies. If the fans go to max speed, this usually indicates either a problem with the PAX reset line in some cases, or the typically the GPU V-core. If it's a V-core problem, that would be kind of characteristic. These Vegas often have V-core problems, and they're not very easy to solve. So for a Vega with a V-core problem, let's assume it is a V-core problem. If it is, what I usually do is I usually try to use the card so that it degrades to a point where it no longer boots. Because once it no longer boots, and let's say fails every time and always fails, then it becomes easy to fix and easy to diagnose because you're not chasing some intermittent issue. So anyways, let's power on the card and let's use the X16 slot actually. I really hope this is not a waste of time. Okay, so it boots. We'll let it get into Windows and try to install the drivers. I should know that being a Vega, my expectation is not fixable, but we'll have to see. Disk boot failure, hold on. Maybe not inserted properly, let's try again. Oh yeah, 1080 Ti, legendary card. If I didn't fix GPUs, I'd still be using my 1080 Ti, and it still didn't boot. Let's see, is my SSD plugged in? Nope, the cable got loose. Okay, let's try again. Oh yeah, DX11 runs especially well on Pascal. Like NVIDIA really had their stuff together when it came to DX11. Okay, so the Vega is now booting into Windows. But it wants to do disk checking. We'll let it do its disk check. It won't take a minute. So for those who just joined stream, the owner says that this card, it turns on, gets detected, but then it dies right away. I'm not really sure what dies right away means in this case. I don't know if he means it crashes like as soon as you try to boot it, or maybe it crashes on the load or driver install. It might be driver install. If it's a crash on driver install, I'm just gonna say no fix, because the thing about cards that die on the driver install, especially for these Vegas, is that it's usually just the memory. But even if it crashes on the load, it's probably just the memory. It's rather common for these Vegas to have faulty cores.
It's a minor, so it could be crash on the nice hash.
Oh yeah, crash on the nice hash, or maybe there's nothing wrong with it at all, and I'm having my time wasted again, just like the last card. Okay, so the Vega already has drivers installed, and it seems to work without issue. Let's go ahead and run a game. I swear, if this is one of those cards that is wasting my time again. For a card, let's say, dies right away, technically overheating could be a thing. You'd be surprised how common that is. Where there's nothing actually wrong with the card, the owner just has done something wrong and caused it to overheat. Okay, so the Vega is running at full load. It's seemingly just fine. You know, it's running at 1500 megahertz, consuming 250 watts. Oh, yeah. You can thank Greg for that, by the way. Is Greg still here? Hopefully not. Oh shit, he is. Well, I hope he's finally asleep. Anyways, so yeah, it's the microphone is way better because it's a shotgun mic. So anyways, the card seems to work without issue. I have a suspicion this card is also another waste of my time. If you're wondering what I do with cards that are sent in that work without issue, I still charge my diagnostic fee because I have to spend my time looking at the card, and let's just say that I really hate having my time wasted. So if this card is perfectly working, I still charge my diagnostic fee to the customer. Anyways, I'm not going to wait for this thing to crash if it ever does crash. It looks like it works without issue. So let's just turn this off and we'll do one more card. Hopefully we can end on a fix, like a proper fix. So, looking at my repair log, we have, for today's queue, I have, you know what, we'll do an RTX 3090, because the guy, he took it apart, tried to reapply thermal paste, and then when he put it back into a system, the card was no longer detected. Let me go grab the 3090, and we'll repair it on stream, and hopefully that'll be the last card for the day. I'll be right back in about 2 minutes. Oh yeah, drunk raccoons. I used to have I had an Athlon 64X2 as my first proper gaming computer. I had an AMD Sempron, and then I got upgraded to an Athlon 64X2. I think I had the 5200 plus. I might be misremembering, but yeah, as a kid, that was my gaming CPU. Okay, so as you can see, the Vega seemingly just works fine. I have a feeling, based on the last card, this is just, there's nothing actually wrong with the card itself. Maybe it was overheating, but we did reapply thermal paste, so I guess we'll never know. Anyways, last card of the day, it's a 3090. I'm hoping this is actually a fix, because the last two cards were, one of them, 5600 XT, was a waste of my time, and this is seemingly not even faulty. I'll test it again later. Like I said, I will test this thing again later, but just to make sure that it is actually perfectly functional. But like I said, I have a feeling that this is just another waste of time. Oh yeah, the Athlon 64X2s, they were legendary. That's why I had one. It was a great CPU. Great CPU. Lots of fond childhood memories on that. Okay, hopefully final card for the day, and hopefully a fix as well. Unlike the last two cards, where one of them doesn't seem to be broken, and the other is... I'm not going to work on it because of all the prior repair attempts. So, this one is an Asus TUF RTX 3090. The owner says that they disassembled the card, and then they tried to put it into a PC, and the card was no longer detected. And again, he's used packing peanuts, the world's worst type of packing material. What do you mean it's a 3090, by the way? That it should be using packing peanuts? Let's see, is there any customer notes? No, there are not. Yep, that's a TUF 3090. Yeah, that's the point. It's not that he used packaging material. It's that he used packing peanuts of all the materials. I would have rather he used 10 layers of bubble wrap. The thing about the packing peanuts, it disintegrates in transit, and then you get like a lot of these small pieces that hang out, and then they dirty my room. Okay, switch to overhead view. Okay, Asus TUF RTX 3090. Oops. Okay, let's just I would normally just, okay, we'll plug it in after checking 12 volts in the PCI Express lanes, just to confirm it is not detected, but we'll have to take it apart, of course. So, starting with the 12 volts at the PCI Express slots, we are perfectly good, checking 3.3 volts. We seem to be open line, that's because my multimeter probably can't get a reading. 12 kilo ohms, that's fine. Checking PCI Express lane, the first one, 1.9, checking the second one, 1.9, checking a random one, just for calibration, 1.9, yeah, that's good. Now let's check the back. We'll be checking PAX resets, and reference clock plus and minus. So PAX resets, nothing, that's fine. Reference clock plus, I think it's plus, it might be minus, 0.85, checking the next one, 0.85, okay? Checking PCI Express slots, 12 volts I mean, so not the slot, the external A pins, yep, that's good. Checking the other one, again, perfectly good. Okay, let's go ahead and plug it in. Just to confirm the symptoms. Seems to power on. Not detected. Okay, let's take it apart. Yeah, the tough cards, well, they're not very tough, and they also, I think they look, they're kind of ugly, on top of having a weird name. So for a card like this, the first thing we want to, well, not the first thing, but we expect to find a knocked off components, given that the owner took it apart, put it back together, and then the card did not work. Okay, so no obvious physical damage with just using my eyes. So we'll look at it under my microscope later. Okay, first things first. Let's check. We already checked 12 volts and 3.3 volts. We're gonna start with 5 volts, which is this here. So they use what looks like an MP1475, and we have 2.1 kilo ohms. That's fine. Now we want to check 1.8 volts, which I presume is this one here. 300 ohms, that's again fine. There's quite a bit of variation for 1.8 volts on these 3090s and 3080s. Now we want to check the PAX rail. I think this actually turns on next, or maybe it's the encore. 4.6 ohms, perfectly fine. And finally, let's check the memory. 38 ohms, again, perfectly fine. So let's clean it up, plug it in, and see what voltage rail we're missing. Okay, let's see. Hopefully we're just missing a power rail and it'll be a relatively simple fix, but checking the PAX rail, nothing. 1.8 volts, which we have. Okay, so we don't have the PAX rail. Presumably we won't have enable on the PAX rail, so... Oh. Oh, right, yeah. Thanks, Fyro. I didn't notice that. Anyways, like I said, so for those of you who are on stream, we have a RTX 3090 who maybe just joined. We have an RTX 3090. The owner took it apart, added some of his own thermal paste, which is a good idea, by the way, unless you're voiding your warranty, in which case it's an awful idea. And then he put it back together, and the card was not detected. When we power on the card, the thing that we notice is that we're missing the PAX rail. The PAX rail powers the PCI Express portion of the GPU, responsible for communicating with the CPU. And the fact that it's not powered on means that it's obviously not going to be detected. Now, typically speaking, what happens on a lot of these tough cards is that the components in the... Hold on, I'll just show you from an overhead view. Typically speaking, is that the components in the top left around here and on the back side often get damaged due to mishandling. So we're going to take a microscope and see if we can figure out, or if we can spot any damage, I should say. I'm hoping it's a very simple fix, but we'll see. Actually, there's one thing that I spot that looks a little weird to me. Let's go to the microscope. Could it be this easy? Okay, what do you notice about that resistor? Notice how it's a bit off-center? It's... Hold on. Not only is it off-center, but notice how this is burnt plastic here. Maybe not. But this is flux, I think. Looks like flux, so prior repair attempt. Not really too surprised there. Lots of dust. This thing looks to be... Yep, this is actually soldered on properly, despite how it looks. That has some damage. Oh, there we go. There's our missing component, presumably. So that would be the very last pin. Last pin should be, I'm actually not sure. Hold on. Let me look at the datasheet for GS9216. I didn't realize I accidentally exited Discord. Sorry about that. Should have told me in chat.
Oh, it just happened.
For those of you who don't know, you can use the data sheet, or at least the following one, in order to, as a data sheet replacement for the GS9216. So the AOZ2261 NQI-11. They are both used as the 1.8 volt buck converter on a lot of these 3080s, 3090s, etc. And because of this, they're generally thought to be interchangeable. But anyways, looking at the data sheet, we're looking for the very last pin, and we have soft start. Okay, so this is the soft start capacitor, which is definitely needed. It sets the ramp time for the capacity how should I put it? So that the voltage goes from 0 volts to 1 volt. And this is not something that we can just, well, you can kind of guess it, but you don't really want to. So let's see, maybe it gives you a typical application circuit, I'm hoping. Okay, no typical application circuit here. Okay. Yeah, I'm not a, for those of you who are asking about subs, I'm not yet a affiliate or partner. I have all the requirements for, whatever the lower tier one is, I think, affiliates, but I have to stream for 3 more days, and then I become, I think I become affiliate. I'm not too sure how the Twitch process works. But anyways, for those who just joined, we have a missing component over here. This is the soft start capacitor, and that's why the PEX rail doesn't turn on. So the soft start capacitor, unlike a lot of capacitors, cannot really just be guessed. I mean, you can kind of guess it, but you don't really want to if you don't have to. So I have to go look through over some of my other boards, see if I can figure out what this will be. Very likely this is going to be the exact same as, say, another 3080 or 3090, despite the fact that this is an AIB model, and the ones that I have are technically reference boards. Okay, so apparently on some cards they use a 2.2 nanofarad capacitor, so I have to go find one of those, and then we're going to put it on, and we should be good. Hi United Game Hub. I should note that I haven't actually repaired your Seahawk yet, so we restored memory power to the memory phase, but it has errors on one of the memory banks. I don't have a replacement memory bank on me at the time, and that's why I didn't replace it on camera. So I have to go reball a replacement memory module and then try to replace the apparently faulty memory bank on your card. I should note that your card's a little worrying in that it has a very low resistance on 1.8 volts, which usually means a dead core. So don't get your hopes up just yet. It's not. I don't know its final condition. Anyways. So for this particular card, 3090, I have to go find a 2.2 nanofarad capacitor, and when we put it on, we should be good.
up, everybody?
Hey, Metal Gear. How's life?
Doing good. I'm hearing that you got the same issue I have with a tough 3080.
Oh, knocked off capacitor?
It's not detected. I got it yesterday. I haven't really had to go too deep into it. I did all my resistances and they're fine, but I had to like stop before I could start checking voltages. It was not detected. Does the one beep and then the three beeps.
Okay, okay.
I boot it. I just woke up, so Plugged was like, "Hey, Tech's streaming and he's got the same problem as you." I was like, "Oh crap! I'll check it out."
I doubt that you have the same problem as this. This one's a bit of a rare thing. This thing, what you see here, doesn't basically never occurs naturally. Usually, somebody knocks off a component just like this. So give me a second. I have to put the capacitor back on. But yeah, so if you're missing the PAX rail, that might be why. Though you could just have a dead core if you have a problem with the PCIe lanes. That's kind of a common thing.
Okay, mine. Someone modified it and removed a lot of the fan shroud and like with a hacksaw, I think.
Oh, they thought it took you.
So I think that they might have knocked something off or physically damaged it. If I could find my iPad, pull up your stream. There you go.
Also, while we're at it, we'll replace this capacitor because it looks kind of damaged. Or at least scraped. And while we're at it, let's check for continuity between yes, if it's fine. I mean, if it's attached, it's attached. How it looks is not relevant. We just care that it actually bridges the two sides and it has a rather stable connection. So anyways, like I said, I'm gonna check the check resistance on that part to see if we have connection between those two ends. So yes, it's connected properly. So I should note that's probably yep, that's connected properly. I mean, it doesn't look that great, but it is connected. Anyways, let's put it on the bench and see if it boots. Yeah, 32 views. Okay. Let's see, there's a 3090 finally boots. Oh. Zero volts. Okay, let's check all the okay, so standard checks for a buck converter are VCC enable voltage in. So we're gonna start with voltage in. So that should be, I think it's this end here. That's probably VCC. Let's check this capacitor. Hold on, I have to wait for my computer to shut off properly. Okay. Voltage in. Maybe other side. No, we don't seem to have voltage in.
Ooh, I have an inquiry.
Oh.
Vega 56.
Okay, I'm gonna guess that's the voltage in resistor, which kind of think of it looks pretty awful. I mean, it looks damaged at least. So checking resistance on this resistor. Oh, 400 kilo ohms and rising. Okay, we need to replace this as well. So this is a 2.2 ohm resistor. We'll just grab another 2.2 ohm.
He says memory gets hot, so fan goes to max. Thermal paste changed. What?
Fyro, would you by any chance be able to tell the marking on that resistor? I know it says 2.2, but does that mean 2.2 ohms? Or no, that would be 2R2, right?
Yeah.
Is this what is this, 2 kilo ohms? Hold on, let me look at another one. That's a 202, so that one is 2 kilo ohms from memory.
And of course I'm not seeing anything on Google.
Actually, no, this thing is connected to 5 volts, not 12 volts. No, it's not the voltage in, it's the VCC resistor. Yep, so this is just this resistor, it's VCC. And I think it's supposed to be a 2.2 ohm resistor, which means I need to go find one from one of my donor boards. Give me a minute. I need to go look through my donor boards for a 2.2 ohm resistor. As no, I don't have any of those lying around. At least in my shelf. And good morning, Mikhail. Unfortunately, you caught us at the end of the stream. We have just this one last card where we've diagnosed the missing VCC, and once we have that working, it should be a functional card. Oh, we can use that one there.
Yeah, that's also good.
What's up?
I previously worked on a Vega 56, but I don't remember. Is the HBM2 modules at the same height as the core?
Not always, no.
Thanks.
Okay, let's see. Do we now finally have PEX voltage? We do. 0.97 volts. Do we have V-core? We do. And it posts. Okay. We are done. Essentially. Let's put it back together and test it. And of course clean it up a little first. Yep, they have installed. They have quietly launched a 3080 12 GB. I've heard. So I should note that for these 3080s and 3090s, I usually change the thermal pads, but I can tell that the owner has put in his own custom ones that are, as far as I can tell, the expensive kind. So we don't need to change these, as that would be pointless. Now let me find his cooler. Well, backplate first. I'm guessing they don't stack VRAM because of heat. So, I mean, GTX at least is kind of warm, so they probably don't do that. And also, the thing about these 3090s is that the VRAM is... Hold on. Where does it not go in? Oh, that's right. So the VRAM is actually kind of stacked. The pairs you see, they're matched, in a sense. Oh, hold on. Wait, no, I'm making a mistake. These are not the right screws. We're supposed to use the black screws. Yeah, so the real purpose of these nil cards is because Nvidia wants to make the scalping price the official MSRP. You know, obviously they want more money per card, and they always want higher prices. So, Metal Gear, do you have 1.8 volts? It's this one over here. If you don't have 1.8 volts, that's your problem. So the way it works on a the power sequencing for Asus Ampere cards is actually different from regular Nvidia cards, as in from everyone else. So basically, I might have it slightly wrong because I can't remember exactly, but basically the part that I do know is that 5 volts is first, followed by 1.8 volts over here, and then I want to say it's the Encore PEX V-Core memory, I think. I don't remember the exact power sequencing, but if you ask again later in Discord, I can tell you. I have to go look it up again. And yeah, Ali Saif, sorry if I pronounced that wrong. Alice If, sorry. Yeah, that's right. Anyways, I wish they would eliminate the quadro tax. Like, I kind of wish AMD or Intel would come in and just basically give you all those quadro features, most of them at least, on their non-quadro cards. That would be heaven to me, at least. So for those of you who just came in, this is a 3090 Asus TUF RTX 3090. The card was not detected due to a dead VCC resistor on the GS9216 and a missing soft start capacitor. We replaced the capacitor with a 2.2 nanofarad capacitor ish, and we replaced the VCC resistor with a 2.2 ohm resistor, which is what it's supposed to be. Okay, now let's go put on the actual cooler itself after we clean it. Okay, so do you have the Encore Metal Gear? Hold on, we're missing something. Where is the front plate, the memory plate? Here we go. That's what I don't have. Yes, so GPUs are made in batches. Basically, batches have varying levels of quality to them. Some of them are really high quality, and you can take, let's say, let's use GA102. So if you let's say have a really high quality GA102 die, you can make it a 3090. But if it has lots of defects and has, let's say, a partially dead memory controller, you can laser off the dead portion or use eFuses and then make it into a 3080. So a lot of 3080s are just actually rejected 3090s. Yep, basically. I'm sorry, what? The crack hack crack? Okay, so as you can see, we now have a repaired RTX 3090. It was relatively straightforward. So just for those of you who are maybe just joining in, this 3090, the owner disassembled it, put in new thermal pads. When he reassembled the card, it did not work. It was not detected. We found that it was missing the PEX voltage due to a damaged resistor, damaged capacitor on VCC for the GS9216 PEX buck converter, and it was also missing the soft start capacitor, which is supposed to be 2.2 nanofarads, I think. Anyways, we replaced all the components. It now boots. It'll stress test fine, given its problems. Oh yeah, yeah. So the 12-gig 3080. I think Moore's law is dead. He made a video on the 3080 12 gigabytes. Basically, they're stopping. They're stopping day one reviews because they don't want to get blasted for being, well, let's just say anti-consumer. Yeah, it is generally bad for power efficiency. I'm not sure if the cut pots do still take power, but they're at least there. So it is good for heat transfer though, because the cut pots, because they don't produce heat, it means that the thermal density is a bit better. Anyways, as you can see, the card boots and it'll run a game without issue in a moment when Steam starts. No, it was just knocked off capacitor, partially knocked off broken resistor, and then another scraped capacitor. And that's the drivers installing, or no, the game running, okay? Yep, no surprise, it works. Relatively easy fix, definitely easy fix, just knocked off components on the PAX buck converter. I'm a bit surprised by the prior repair attempt, hopefully not the owner's, but yeah, it's a fix. The card works. So far for stream, we've looked at 4 cards. There's the 1070 Seahawk, there's the 5600 XT, Vega 64, and now 3090. So 1070 Seahawk, yeah, loud quote. I'm sorry, man. It's also my microphone. The positioning is not so great. So for the Seahawk, I don't really want to look at any more Neo customer cards at the moment. So since we have the fail result for the Seahawk, I'm gonna go reball a memory module off of one of my donor boards, and then we'll put it on the Seahawk, and we'll see if it works, and then we'll end the stream. So let me go find some Samsung GDDR5 as well as the owner Seahawk. Also, I'm gonna take a 3-minute coffee break. It is actually, yes. So the Seahawk is actually right behind me. Give me a moment. I need to take a memory module off of the donor board, and then we'll reball it and put it on the Seahawk. Oh yeah, definitely way more performance. Well, not performance, but cooling. Yes, way more cooling. So performance not so much, but they should at least overclock better, provided you have a decently bin core. Okay, so we have our replacement donor memory module now. Let's go get the owner's card. Let's turn this off as well. So previously we had a B1 on the card. So at memory bank B1. This was the entire memory module. I'm a little worried. It's a dead core or dead memory controller. But what we're gonna do is we're gonna run mat on this one more time to make sure that it is B1, and then if it is, we'll replace it. So let me reconfigure mats. And we'll set it to power off, so it does actually power off. So this will take a while to this will take a minute to post, and then you hear that beep, and the monitor will be blank, but there will, actually I think last time there was an artifacting image, but that's not what's supposed to happen. It should be just blank with a backlit monitor. Anyways, while that thing completes its test, we're gonna reball our donor module, Samsung GDDR5, because taken from another card, because I don't have I don't keep Samsung GDDR5 stock, because they're kind of rare for the cards that I do repair. If you want, I can give you a cooler for the card. I should have a spare. 1070 cooler around, unless I threw it away recently. I don't remember if I did. But I won't have a backplate for it. Okay, so Matt's ended on the Seahawk 1070. Let's just look at the reports. Like I said, it should be B1, but let's just double check it.
Hey TC, you still streaming?
Yes, I am actually. I'm on my last card. What's up?
Okay, I had a GPU question. I'll ask you later.
Okay, sure. Anyways, and so those are on stream. We're looking at the we're about to look at the match reports, and as you can see, we have errors on B1. The thing to note here is that they look rather random, like it's the entire memory bank. Or actually, no, it is the entire memory bank. It's the entire it's, well, 32 bits. Failing bits are 32 to 63. This is the entire memory bank for B1, and this here 1,974,000. This is the maximum possible number of errors, roughly speaking. This is I'll be honest, I'm not sure what to think of it in this case, but let's go ahead and replace the bank. So yes, it's B1. Let me just disconnect my USB drive. And before we work on the card any further, let's just confirm it is actually Samsung memory, before I do something stupid. Yep, that's Samsung memory. And looking at it, I don't see any knocked off components on the back, so I don't think that's the I was hoping it'd be easy, but I guess it really is the memory bank in this case. Anyways, let's go ahead and reball our replacement bank. Yeah, it's not for dust. When I put soda balls, I don't want it to fall off the jig and then onto my desk. So if instead the soda balls fall into the plastic bag, and then I don't have to clean very much. I don't have a 3D printer, no. I should, I probably should get one eventually. Yeah, I'm not fond of it either, but you know, have to do it. It's I would normally just replace it with a already revolved chip, but I don't keep Samsung GDDR5 usually. Okay, so we have a replacement memory module, and we already know our suspects. So our suspect being B1. For those of you who don't know the order, the ordering is A1, A0, B1, B0, C1, C0, D1, D0, which makes this our suspected memory bank. So anyways, let's go ahead and replace, take it off and replace it. Hopefully the card will work, but we'll have to see. So what I'm going to do is I'm going to preheat it from the back, and then we're going to turn the board over, and we're going to take off the memory module, and then of course replace it. Actually, hold on. Let's take off this plastic. Sometimes these get burned even when they're far away. Okay, let's get back. Good. Shit, whoops. Few solder balls here, and we'll clean this later. But for the time being, let's get rid of the solder while it's still warm. Why would I use preheat over a soldering iron and a heat gun, Pipsy? Hi, Monster. What's up? Not on the first pass. Yeah, I hope it works too. United Game Hub. I hope it works too. We have to let it cool down for a bit though. So unfortunately, it's still kind of warm. So we'll give it like 2 or 3 minutes, and then we'll try to boot it. I'm gonna take a 2-3 minute break. I'm sure. I'm sure. Okay, cool enough. Let's see. Does it post? Does it post? Unfortunately, I think the answer is no, but let's put the cooler on. That's why we're gonna run Matt's Fipsy. Actually, it does post. There we go. Sorted correctly. Congratulations, United Game Hub. I think you have a working card. I have to test this. Actually, let's just actually test it. No, actually, let's take the cooler off. I want to try something because it didn't post last time when we first booted it. Maybe my motherboard just taking its time, but I want to see it post with no cooler on. I want to see it post with no cooler on.
Maybe it's getting hotter than usual because of the usual 1.8 volts.
Maybe? I don't think so. I mean, actually, while we're at it, let's just check 1.8 volts. It was 432 ohms before. This can sometimes be due to a BIOS, but yeah, I don't know. You sometimes see this on EVGA card. So let's see. Does it actually post this time with no cooler on? So if it posts, it'll drop to 0.7 volts, and you should hear a beep straight away. Hangs. My guess, post with the cooler doesn't post without one. I think the core, I mean, I can't believe I'm saying this, but it sounds like a soldering issue with the core. If it can post without a cooler, sorry, if it cannot post without a cooler, drops to 0.7 volts, but hangs and stays there. But if we put the cooler on,
Isn't that full fan speed?
Yeah, yeah. I think you have bigger problems with this card. 432 ohms on 1.8 volts. Without the cooler on, it cannot post, as you saw. At least it can post, but it takes a minute. With the cooler on, now max fan spin, but posts. Okay, let's take it out. Was I careless with the connector? Yes, I was. Okay, let's try that again. Only partially connected connector. Yeah, it's just the fan header. My mistake, sorry about that. But yeah, anyway, so this is actually not a fix. So it cannot post with the cooler off. Obviously, it takes a minute. It'll probably be matte, but it can with a cooler on. So in my experience, cars like this, they usually, even though you can just run it on a cooler, even if it, let's say, works without issue, after a couple months, you have bigger problems. So that's matte, by the way. Looks good so far. Yeah, I have to fix my audio. I'm sorry.
Maybe I should start fixing ASICs boards.
Okay, so for this particular card, I'm gonna say I think you have a solder ball issue under the core. So as you,
Pass? What?
yeah, it's okay. So let's go over the card. This card has 430 ohms on 1.8 volts. Right now we're just ignoring it. It was missing memory voltage. It was due to a dead resistor that connects 1.8 volts to enable for the RT8816. We replaced the dead resistor. We have memory voltage, but then we have memory problems at bank B1. We replace B1 without the cooler. It either does not post or it takes a minute to post. Probably takes a minute, but with the cooler, it posts instantly. So I think likely you need to reball the core. I cannot do this, unfortunately. I don't have the tools, and well, I also don't. I can do everything but put the core back onto the board because I don't have I don't have a proper rework station. At the last Matt's test, for the when the card originally failed at B1, it was every failing bits, all of them.
1.9 milliamp hours.
So anyways, before we replaced B1, the failing bits were 32 to 63. Everything. 32, 33, 34, all the way to 63. So anyways, I think this card has probably a solder ball issue or connection issue under the core. Or maybe even inside the core itself.
Did you put your finger to see the temperature on the core?
I'm sorry?
Did you put your finger on the core to see if it was getting overly hot too fast?
I did not. So before
Because
before I replaced the memory module, it was normal. The heat was normal. What a shame. So I gotta ask, United Game Hub, what happened to the card before it died? Like, was it just random out of the blue, stopped working? It seems to have an awful lot of problems for just one card. Ah, eBay. That makes sense. Yeah, well, well, you could probably use this for like a couple months at most, I would say. But then eventually it would probably need a reball. Yeah, I think it needs either a reflow or there's maybe a damage trace inside the board. I can't do a reflow. I have the equipment for a rework station, but I don't have it set up. And I might try to set it up, but I don't think I can get it set up in just like an hour or two or even a day.
well, I do.
What, do you have a reflow station, Fyro?
But I have a preheater. I can do core swaps.
Oh, oh, that's right. You have nothing. Well, I mean, I'm not gonna bake it in the oven. We don't do that kind of stuff here. The proper way to do this. So the proper way to do this. Actually, maybe it's not the core. Actually, try a bench on the card. Let me try something else. I'm gonna try to push down on both the memory module and the core. I'm hoping it's just maybe not so great solder on the memory module. I'm hoping it's just a silly mistake that I've made, and if I reflow it, it'll work. I do, Saudi OC, I do. Sure, sure. Actually, let's look at it. Let's look at it under a microscope. Maybe it's just some edge soda ball. Connect fan header without mounting the cooler. Okay, sure. We can give that a try at this point. I don't think it'll work, but you know, you might be right. Oh, actually, no, he's completely right. Okay. Hold on, let me just connect it without mounting the cooler.
Oh right, it was an AIO card.
Yeah, I'm just remembering, embarrassingly enough. Okay, we'll just let this hang briefly. And connect the HDMI. Okay, with
Still, most cards, even AIOs, they don't have fans, pump speed to shut off.
that doesn't seem to work. Again, we'll check 0.7 volts. If VCore is 0.7 volts, it initialized. 0.8 and then 0.7. No, nope. It needs a cooler. It needs the mounting pressure. Yeah, I'm gonna guess I think it's a connection issue at the solder balls. So a reflow technically would probably be a temporary fix for this card. I see no damage on traces. No, I think it's just a simple solder ball issue. You know, without the cooler on. Actually, let's get I'm gonna get a 120 milliliter. The thing about 1070s is that they run cool enough that you can run a memory test with no cooler. I'm gonna get a 120 millimeter fan. We're gonna run mats. No, I don't use a riser. Yeah, this cooler only pushes against the GPU, not the RAM. These these cards, this particular model uses a memory plate for the RAM. Actually, come to think of it, Fire, you remember earlier on stream when I connected the HDMI ports, there was actually artifacting on the screen, right?
Yep.
You think that could be a solder issue as well, due to maybe you know, under the solder balls for the HDMI? Because I remember that normally for a 1070 there should be it's a blank screen but there's no image, but we had artifacting.
Yeah. You mean the data lines from the HDMI port to the core?
Yeah, I'm gonna check that after we run maths. Oh yeah, I know. Sometimes you have artifacting. I've seen those before. This one, I don't think it was memory artifacting. Hold on. Did maths even run? No, it didn't. I know. I've seen your streams, Jericho. Yes. Yes. For this one, this USB drive, yes. By buying them broken off of eBay and wasting lots of money and time. Same with basically everyone else who learns how to fix graphics cards. You can ask Jerop here. I think he started on GTX 760s off of eBay. I started on GTX 1070s. Like this one. Also, by the way, not all my videos are correct. Some of my early ones have a few mistakes. Mass doesn't seem to want to run, but there is one thing I want to check. So I want to check the HDMI lines on the back. So there are these capacitors. From memory, I think they connect directly to the core. There's at least some data lines. I reckon if I find the right data line, I'll get open line for some of the capacitors, but when I put the heatsink on, it'll be, well, connected. If it is, I'm going to say needs a reball and we're done. Let's see, is it this end? 0.3. Okay, that's not going to work out. Yeah, maybe it does need ultrasonic cleaning. Though, I'll be honest, I'm not too sure what to think of this card. See, okay, it can post and even perform normally with the heatsink on, but without it, it doesn't. Not only does it not post, well, it posts after a minute with a backlight, but it doesn't seem to run mattes for some reason. I almost think it's not a memory thing, maybe. Any suggestions, by the way? Let me go grab my display port to HDMI adapter, and we'll try a different port, and maybe then mattes will run. I don't have too many ideas anymore, besides a reflow, and I can't do that here.
if it's like very likely a cracked solder ball or something, I can probably reflow it for you. But I live in Canada, so there'll be import fees and stuff.
Sure, sure. Well, I'll try mats one more time on DisplayPort. If that doesn't work, after a minute, we'll do mods. I did not. I checked the first data line. Not all the data lines for the PCIe lane that is. But I did not check the DVI ports. Is there something special about the DVI port that I should know about? So I checked the HDMI since that seems to be the one that's... Okay, let's put a cooler on and just run mods. It'll tell us. Yeah, sure, go ahead. What's up? Do you know how to put a GPU core back on? Have you ever done one? Because even if you do, the answer would be no. Generally speaking, you do not want to subject a core to the amount of heat required to remove it from the board and then put it back on. You know, you can only take off a core from the board and put it back on so many times before you've essentially burned it. The same goes for memory chips and every other component. Yeah. With so it's just due to mounting pressure. Like I stick to my assertion. Oh, hold on. I have to grab a keyboard for this. Give me a moment. Anyways. So far, it's just frozen. It's been frozen on the same screen for about a minute now. Error while executing frequency controller load RPC. Timed out while waiting for PMU command completion. And it's artifacting all over the screen. I don't think you guys can see this, but I can definitely see it.
Yeah, somewhat.
So it fails. Okay, because it's artifacting on the screen, we should be able to just run maths and see what's faulty. A1. So A1 has errors. So I still think it's a solder ball issue. So it's the entirety of A1 that has issues, but I mean, for this card, the entirety of B1 had issues as well. And we replaced B1, seemingly works. GTX 1070. Honestly, I'll replace A1 tomorrow. The memory bank A1. If that doesn't fix it, I'm gonna have to say I spent enough time on this card. Unfortunately, it seems like I do think it's a solder issue under the core. Okay, fine. We'll have a part 2. We'll look at it again. I'll reball another memory module off camera. But like I said, we'll replace A1. If not, I'm gonna go with the core needs a reflow, or there's some deeper underlying issue, or it's the board itself. But this card is taking way too much of my time, and I have other stuff I have to do today. Anyways, that'll be the end of the stream. So anyways, does anyone have any questions before I end the stream? Oh, I'm sure, but I'd rather not remove a GPU core. It's definitely time consuming.
Send it to me, I will.
Well, Fyro says he'll do it, so if you want to contact Fyro after I replace the memory bank, we'll give it a try. Anyways, yeah, sure, see you at United Game Hub. Thanks for tuning in.
Oh wow, it's 11 a.m.
Yeah? Oh, yeah. 10 a.m. over here. Sure, anytime. I think I'll probably stream roughly the same time tomorrow. This will be the first card. This will be the first card, for sure. Otherwise, yeah, see you everyone. Anyways, I'm gonna end the stream because nobody has any questions. Hopefully I'll see you all tomorrow again, and hopefully the card will work when we replace A1. Thanks for watching, and I hope you learned something.